Two important examples of formulas that are valid, namely formulas that are true under any valuations, are the principle of excluded middle and the principle of non-contradiction. I'm going to abbreviate this by saying PEM and PNC, principle of excluded middle and principle of non-contradiction. The principle of excluded middle is the first formula that we see here on the left-hand side, and it reads phi or not phi. So this principle says that either things are in a certain way or they are in the way opposite to that. Here is an example. The sun is shining or the sun is not shining. So it's called principle of excluded middle because a third possibility or middle possibility is excluded by this principle. On the right-hand side, we have the principle of non-contradiction. Why it's called the principle of non-contradiction? Because this formula here between parentheses is a contradiction, is the assertion that phi and not phi. So an example would be the sun is shining and the sun is not shining. Saying this is a contradiction. So the principle of non-contradiction denies the possibility of a contradiction. It denies the contradiction that is expressed between the parentheses. These two formulas, or these two principles, excluded middle and non-contradiction, are valid. This means that they are true under any possible valuations, and this is relatively easy to check. So let's consider the truth table for the principle of excluded middle on the left-hand side. So we can assign value 1 to phi, or we can assign value 0 to phi. These are the only two possibilities, and phi is any formulas. Now, if phi is given value 1, then not phi must be given value 0, and if phi has value 0, then not phi must be given value 1. This is just by the truth table of the negation. Now, if the two disjunct that we need to consider now are phi and not phi, and these are combined by the OR symbol, which is the disjunction here. Now, if one disjunct has value 1 and the other disjunct has value 0, so one is phi and not phi has value 0, then the value of the disjunction is 1. If, on the other hand, the first disjunct phi has value 0 and the second disjunct non-phi has value 1, then again the value of the disjunction is 1. So here we can see that no matter the evaluation function that we pick, the truth value of phi or not phi is always 1. The same happens with the principle of non-contradiction on the right-hand side. You see that it always has truth value 1, no matter the valuation that we pick. So even if we assign 1 to phi or we assign 0 to phi, we always get truth value 1. And I leave it up to you to check that in this truth table, that the truth table is indeed properly constructed and that the principle of non-contradiction, not phi and not phi, always has truth value 1. What is important to note here is that we can get this result of the two principles always have truth value 1 because we have assumed what we called earlier in another video the principle of bivalence. So this principle of bivalence is the principle that says that any formula has a truth value either 1 or 0. There is no third possibility. And so you see here that we assign to phi truth value 1 or truth value 0. There is no third possibility. Now, I said earlier that it is thanks to the principle of bivalence that we can show the principle of excluding middle, PEM, and the principle of non-contradiction, PNC, to be valid, namely to be true relative to all possible valuation. A natural question at this point: what happens if we drop bivalence? What happens if we drop the assumption that we can assign only truth value 1 or 0 to the formulas? And I leave this as a question for you to think about.